of course. Yeah, this is the first public outing, so to say, of the AURORA project that we have been planning for. The AURORA project is something we've been planning now for almost more than a year. And AURORA deals with, as Andreas will tell us in more detail just in a minute, AURORA deals with sustainable agriculture in the Middle East and Northern Africa, the MENA region, and from a certain perspective, from the social ecological systems analysis perspective and related frameworks. Like I said, more of this Andreas will talk in a minute. So I would first like to introduce our partners. That is the Food Security Program of the American University of Beirut, which together with us organizes this webinar series. We have the IAV Hassan-II from Rabat, Morocco. And from Tunisia, we have 3 partners. One is the National Research Institute for Rural Development, Water and Forest, in INRGREF, INRGREF, and the Institute of Agricultural Research and Higher Education, IRESA. And finally, the École Supérieure de l'Agriculture de Mograne, ESA Mograne. And we are, of course, from the Department of Organic Agriculture of the University of Kassel in Germany, and from the section of International Agricultural Policy and Environmental Governance within the Department of Organic Agriculture. So you can see it's quite a large consortium coming together here, different partners from 4 countries, and we hope to achieve a lot over the next years. The project is financed by the German Academic Exchange Service, DAAD, and affiliated with a number of other programs. For example, the Global Partnership Network, GPN, of the University of Kassel. And of course, it is endorsed by the IASC, which is the International Association for the Study of the Commons. And they will also play a role in later webinars, because this is the first of 5 webinars in the series, which will run through January, from now to January, every month in mid-month on a Wednesday at 5 o'clock. So just some short notes on the program today. After this very first introduction, Andreas Thiel will tell you more on the key ideas and core concepts of AURORA. Andreas Thiel is, of course, the head of section of International Agricultural Policy and Environmental Governance here at the University of Kassel. And after that, we have our keynote speaker, Professor González de Molina Navarro, who is professor of modern history and also coordinator of the Agroecosystems History Laboratory at Universidad Pablo de Olavide in Sevilla in Spain. So we're very happy for Professor Molina to be here today. And after the keynote, we will have the opportunity to approximately exchange questions and answers and discuss a bit for about 20 minutes until the hour is already over. Yeah, and again, I will ask you to use the raised hands icon and write something in the chat. So with all of this, again, thank you very much for your interest and for being there. And I give the floor to Andreas Thiel, who should be able to share his screen.
Thank you very much, Sören. As we were with introductions, let me also introduce Sören to you. He's the program coordinator, the project coordinator really for AURORA. So he tries to keep this enterprise on its feet and on schedule and delivering all the wonderful, in fact, ideas and how to make them concrete into deliverables. So thanks, Sören, for the introduction, really. very welcome to everyone. I'm extremely pleased and I feel extremely honored to now be able to present the AURORA project to you, which we conceptualized a year ago together with a very strong group of partners from American University of Beirut in Lebanon, from INRGREF, ESA Mograne, IRESA, three very distinguished institutions in Tunisia, and with colleagues from IAV Hassan-II in Morocco, located in Rabat. People we are working together with on several projects, and we're extremely happy now also to be able to present and start this AURORA project and finally go public. And also I'm extremely honored and feel very pleased to have Manuel Molina with us today, Professor Molina from University of Pablo de Olavide, and I'm really looking forward to his intervention. He's got some really interesting and fascinating group of scholars around him working on very forward-looking agendas, very relevant for us and for the MENA region. So I think we're going to learn a lot from him. And so I better hurry up and do quickly my presentation on the conceptual approach and what we try to achieve in the AURORA project. So I will, although I have quite a few slides, I will try to go through them in a rather swift manner. So we are facing problems, not worldwide, as has been just discussed in the preliminary conversations everywhere, also in Germany and in Spain, but certainly also in the MENA region, and the agri-environmental systems in that region is facing multiple challenges such as low productivity in parts of agriculture, water stress, overexploitation of natural resources, growing population, demographic change, and food security in part is under threat. And the idea of this project is really that through promoting an interdisciplinary framework that addresses particular contexts and that does justice to contexts, we can maybe come to better crafted solutions and ideas for generating and improving food security and better and in a more sustainable way addressing agricultural and food security issues. And all of that is obviously very relevant in various ways to the very interdependent sustainable development goals with which I'm sure many of you are very familiar. Now, why do we think this is important, and what are the key elements of the approach that we want to propose and that we want to work with throughout the next couple of years throughout the AURORA project in order to make our contribution to better understanding and creating better solutions and approaches for food security in the MENA region. As I'm sure many of you know, and this is in fact an example more from the Northern Hemisphere, agri-environmental problems are discipline passing. No, they are overarching. We need chemists, we need hydrologists, we need ecologists, we need agricultural economists to understand, for example, why the fishing population in this estuary goes down. No? We also need lawyers in terms of understanding the regulations. We need resource economists that can tell us something about the regeneration of fish populations, etc. No? We may even need urban planners. So we need a lot of disciplines that work together. And in fact, what we most of all need to do, though, we need to combine them in a way that addresses the problem specific to this area. So we need problem-based research, combining many disciplines, and that way we come to a transdisciplinary approach that we think is really a guiding idea for our project that should inform it very much. So transdisciplinary research, what it tries to do is bring together scientific actors and scientific understandings together with societal actors and their hands-on problems, and trying to bring them into a conversation and trying to that way make scientific knowledge valuable and address actually the problems that people face in their particular contexts. And that's the challenge we are facing also in our project, where we want to promote transdisciplinary research. How do we do that? How do we do transdisciplinary and cross-disciplinary work of that kind? There are very basic challenges to doing this, and basic instruments also to addressing it. But they need development, as all of us know that, and they need investment, and that all of us know that work in research projects and that teach and that work in scientific institutions. So we need problem-based common group learning, and that needs to be organized. That means we need to also we need to have maybe spatial proximity. We need integration capacities, people that speak a common language, that can communicate, translate one type of knowledge into maybe more practical knowledge, and that way come to a joint understanding of issues. So this is, for example, one important ingredient really that we want to work with, this interdisciplinary language, this common framework for analyzing problems in a very problem focused and bottom-up way together with stakeholders. So these are the challenges, the anchoring aspects that we want to foster in teaching and in research throughout the AURORA project in research on food security in the MENA region. And what are the core elements of this approach that we want to promote? It's institutions and governance that we think are very important in understanding the incentives and the way people act collectively, which is very important to solving these problems, understanding how people act collectively, understanding how policies, also as an expression of collective action, are shaped and may be successful or not. We also want to foster a shared conceptual framework that helps us to communicate across our interdisciplinary consortium, but also that helps us communicate with stakeholders. We want to not forget about the context in which our agri-environmental problems are situated, which is really a broad and very complex food system context, which translate to the value chain. But not only, there's also climate change aspects relevant here, there's policy making relevant, there's technological development, and there's social aspects relevant, and many more. So these complexities of what actually affects finally food security as an outcome of a food system needs to be kept in mind when we look at local agri-environmental problems. And to do so, we are sure that we'll need to combine multiple methods to properly explore, understand, and maybe at some point also upscale our knowledge in a proper manner. Upscaling in terms of evaluating, diagnosing issues, and seeing what can be translated to other contexts and what cannot be translated to other contexts. So let me elaborate a little bit on these key concepts. First, there is institutions and governance, which are important to us, which can be rules and regulations, but which are also culturally fostered norms, which can be shared strategies. And those are important to understand because they structure human behavior at all different levels. So we think they're an important element to understanding behavior of farmers and their interactions with public agents, etc. So that's something we want to foster. And we want to do so using an established framework, the institution analysis and development framework, that wonders exactly how institutions affect collective action, but it also puts into institutions into perspective by saying collective action also depends on community attributes, and it also depends on biophysical conditions. So we will draw a complex map of the particular problem settings that we are going to look at, because institutions need to be situated in their particular context. So this relatively simple framework very quickly becomes quite complex when we scale up to what is called the socio-ecological transformation framework, which, as you can see here, tries to integrate variables from a food system approach. Now, this is obviously a lot to talk about in just a few minutes, and just a few seconds, in fact. But all I want to say is that there are established frameworks that try to integrate a food system perspective into understanding local resource and agricultural, agri-environmental problem situations that put forward really this food system aspect. That's what we want to rely on. And here you see lists of variables that brings us towards this common language that we want to use and develop in our work. And doing so, for coming to such a differentiated understanding, we will need qualitative data, but we'll also need quantitative data at some point in order to upscale our knowledge. So this is what is ahead of us. This is our challenge, and this is our partners. And this is the way now that I want to very briefly present of how we want to address this challenge and this approach, using this approach throughout the AURORA project. So the aims and the objectives of the AURORA project, as also Sören has already highlighted, it's about curriculum development. It's about infusing these ideas into teaching programs across the universities at first that are partner to this project in Germany, in Morocco, in Tunisia, and in Lebanon, but also then going beyond that at some point through social media, through digitalization and outreach activities. We want to apply this framework and therefore actually think about particular problems. And we want to see also if we can already come to replicable findings of what are issues from an institutional social ecological system perspective on the MENA region. To do so, in order to achieve this, we have a very complex and elaborated project plan ahead of us, where we're going to develop 3 modules that roughly represent these contents. There will be a summer school, there will be case study field trips. There's this webinar, which is part of the project. And there will also be bilateral exchange between the partnering universities. But the long-term goal may well even be to have more established collaboration in higher education through some kind of common thematic master course with such a regional focus. And maybe Pablo de Olavide and the team of Professor Molina even wants to become part of that at some point. There's a timeline to this, and what you see here encircled are the issues that are about outreach. So everybody that is not part of the consortium, and there are many here today in the audience, you're very much invited, and you will hear from us now already as you subscribe to this email list today in order to be part of this seminar and this webinar, when we have a dissemination workshop, when we have a summer school, when we establish our content digitalized and make it accessible. So please stay tuned and be aware of this project, follow it and enrich it, and participate whenever we are able to open up and share our knowledge. And with this, really, a warm invitation to be part of this webinar series, but not forget about us after that, but actually follow the project, engage, and maybe also promote these ideas in your particular context, and be in touch with us. Thank you.
Andreas, thank you very much. And now we head over to our keynote speaker, who please, the floor is yours.
Thank you. I try to share my screen. Okay. I would like to thank Andreas dear and colleague for inviting me to participate in this webinar. I hope the talk will be interesting for you. I will speak a little bit slowly in order to make understandable my talk, because my English is not really good English. Let me know, please, when 5 minutes left. Okay.
Yes, I will.
I would like to discuss with you the following topics: the social metabolism approach, some result of applying social metabolism to a Spanish food system. I will also show you some environmental impacts of a Spanish food system using this tool. I'll say something on agroecological experiences in Spain, how they are constrained by the corporate food regime. And finally, how to change towards a more sustainable food system some note, of course. No? My approach to food system tries to combine the biophysical with the institutional aspects to provide an overview of their main environmental problem. I think this exercise may be useful for designing sustainable food system. This approach comes from agroecology. As you know, agroecology is a transformative science for designing and building social dynamic of change according to principle of food sustainability and using transdisciplinary and participatory methods. So agroecology is I think, a powerful instrument to achieve change in the food regime through the massive redesign of the economic and institutional structure that ruled it. So agroecology has a political dimension. In fact, we have developed this concept that we have termed political agroecology. We have defined it as a transdisciplinary field within agroecology, of course, responsible for designing and producing action, institution, and regulation aims at promoting food sustainability. But political agroecology must be based on sound knowledge that provides a roadmap for the changes that need to be made in the food system. The search for methodologies to help designing sustainable system is, of course, a fundamental task from our point of view. Our Agroecosystems History Lab is engaged in this task by applying and developing biophysical methodologies such as life cycle analysis, land cost of agrarian sustainability, energy analysis, and especially social metabolism applying to agroecosystem and also to food system. But what is social metabolism? This concept is a metaphor taken from biology and transferred to relationship of every society with its environment. From a thermodynamic point of view, human society needs to generate order by consuming energy and material from their environment where dissipated waste end up. So social metabolism studies this exchange of energy and material that all societies make with their environment. Therefore, it provides a biophysical knowledge of society. Although there are different schools on social metabolism, for example, the Institute of Social Ecology in Vienna, the Museum in Barcelona, the School of Metabolic Drift, mainly in USA, Agrarian Metabolism in Mexico or in Spain, the methodological approach that has been most successful and widespread has been the so-called economy weight material and energy flow accounting. This methodology quantifies the flows of energy and materials coming into the economic system of a society and the outflows consisting of consumer goods, services, and solid, liquid, and gaseous waste. This methodology has been adopted by Eurostat and later by the United Nations as a methodology for compiling biophysical account of national economies. When applied to agroecosystem and also food system, this methodology can provide very relevant information to understand the functioning of the food system and propose or point out changes to improve its sustainability. For example, it provides an integrated analysis of the physical basis of food system operation. It points out the critical point of the system configuration and its hotspot of unsustainability. It allows monitoring the transition toward an alternative model, correcting its most unsustainable element at any given moment. So the methodology provides quality information for collective decision making. We have applied the social metabolism approach to the analysis of agroecosystem by combining the material energy flow accounting methodology with the principle of agroecology, making some important modification, correction, or changes. The result has been a proposal specifically adapted to the analysis of any agroecosystem, which we have named Agrarian Metabolism. We have developed it on the basis of its application to the case study of Spanish agriculture from the beginning of the 20th century to the present day, trying to analyze the socio-ecological changes that have taken place and its social, economic, and environmental consequences. There are some of the, in this picture, some of the publication with the result in book form, along with more than 10 papers. The latest of this book is an open access book that you can download from the website of the Springer Nature publisher. This figure summarizes the functioning of agroecosystem, not only from a biophysical, but also from a social and economic point of view. It shows the flows of energy, material, and information coming into and circulating inside the agroecosystem, whether they are biophysical or social or monetary and monetary flows. The relationship that these flows establish with the agroecosystem fund element is a key question to understand the sustainability of its management. I don't have the time to explain it in detail, but I invite those who are interested to read the chapter 1 of the book already mentioned. But the agrarian metabolism had not only helped us to understand the functioning and evolution of agroecosystem, it has also allowed us to develop an ecological theory of political institution extremely useful for political agroecology. From a thermodynamic point of view, agroecosystem can be considered as a complex adaptive system dissipating energy to counteract the law of entropy. Agroecosystems maintain and exchange relationship of energy, material, and information with their physical and social environment. The aim of this exchange is to appropriate agroecosystem biomass to satisfy human species endosomatic consumption directly from the land or indirectly through the livestock, while providing basis ecosystem services. The institution, understood as established social relation, regulate the flows of energy and material within agroecosystem and also regulate access to their fund element, land, livestock, etc., etc. We'll come back to this later. Since 2003, agroecology has taken a food system approach and considered that food must be at the core of agroecological transformation strategies. we have therefore tried to analyze the food system in Spain, trying to understand how it works, its critical point, and on the basis of this analysis, to propose sustainable alternative. For this purpose, we think that the metabolic methodology is the most appropriate one, even though its application presents some methodological and data sources problems. In this case, the life cycle analysis has been very useful to complete the study. Our analysis has focused on the total amount of primary energy used by the Spanish food system and how much it represents in the Spanish economy as a whole. This figure represents the different steps in the food chain that we have analyzed and the main consuming activities involved: agricultural production, food processing activities, packaging, energy consumption in sale and retail outlets, and the energy used in household. In every step of the food chain, we estimate the final energy consumption as well as the embodied energy consumption. Only we have a problem that the result don't provide the whole energy consumption of food, because I have no enough time to explain the methodological problem, but we cannot make a balance as energy analysis does, no? But it's a good proxy of the actual cost of food system. This figure presents the evolution of Spanish food system from the 60s to 2010, the last year with all statistical data available. As you can appreciate, a large number of activities has grown between production and consumption. They have increased energy consumption tenfold, from 181 petajoules in the beginning of the 60s, it has risen to 1,855 petajoules by 2010. Food has become one of the most energy-consuming economic activities in Spain, and therefore one of the main causes of unsustainability. If we take into account the whole Spanish economy, we can see that today 1 out of every 5 energy units is used by the food system. Renewable energies are growing and growing in Spain, but most of the energy use still come from fossil fuel. Although the energy transition must be accelerated, a significant reduction in the energy used by the food system is obviously needed. This is not only desirable, but also, I think, I try to show later on, possible. If we analyze the 2010 data more in depth, we can detect the hotspot of unsustainability of the Spanish food system and why it uses so much energy. Agricultural activity, for example, are responsible for the use of almost a quarter of the energy invested in the food system as a whole. The consumption and manufacture of chemical fertilizer, especially nitrogen fertilizers, we are very energy intensive to produce. Electricity to raise groundwater, which has become the main sources of water for irrigation, and the huge amount of feed used by intensive livestock farming are the main cause of such a large amount of energy use.
This 5 minutes left, sorry.
Sorry?
5 minutes left.
Okay, so only 5 minutes, but Yeah, I am in the beginning, but I try to finish quickly. This fact reflects the predominance of industrial agriculture, so intensive in external input coming from mineral sources and fossil fuel located outside Spain. Also reflects the predominance of intensive livestock farming. In fact, Spain has undergone a big process of, we can name livestocking. That's to say the primacy of livestock breeding activity and the productive orientation on arable land toward livestock farming. It's not difficult to think about how we can change this conventional model. For example, going to the organic farming, reducing thus the use of fertilizer, fossil fuel, and animal feed, as long as this organic farming is based, of course, on agroecological criteria. For example, strengthening the farmer autonomy or crossing biochemical cycle, and so on. Transport along the whole chain is the activity that uses most energy, almost 26% of the total. No? I have no time to detail the analysis of this stage, but I think that a significant reduction in energy use can be made possible by promoting, for example, short channel distribution channel, where a more direct connection from producer to consumer is possible, and where less storage and transport requirements are needed. Most of the food consumed in Spain undergoes some kind of processing and transformation, either by the agri-food industry or for preservation and transport sale. The agri-food industry uses 13% of the energy requirement, and another 10% is invested in packaging activities. Spanish people are consuming more and more processing and super processed food with serious consequences for health, but also for the environment. Reducing the metabolic profile can be achieved by consuming more fresh food and food from local agroecosystem. Finally, you can see here the energy use at home and retail is directly related with the way in the Spanish people cooking and preserve the food. Here we can make also different strategies to reduce the profile of the whole system. I was trying to show you the change in the diet practiced by Spanish people, so long from the Mediterranean diet, but I have no time because the people has is now using a Western diet with a lot of consumption of meat and dairy products. So I try to go to the finish, where in this picture I try to reflect the four main principles that we can take into account to redesign the food system from agroecological point of view. Of course, this is directly related also with the institutional change, with public policies, with the change of corporative food regime, and so many more changes that the agroecological experiences can get only if they get high scale. We are able to scale up the agroecological experience. I think this is the main question I want to put on the on the table for discussion. I'm sorry because I understood that I have 30 minutes to develop by talk, but it's possible. Thank you very much, and I remain for your question if you have somewhere.
Thank you very much for your very insightful and inspiring ideas. Yes, I hope there's some questions from the audience. So please, everyone, go ahead. I think we were all quite inspired. So who might be first? So Andreas, please.
Well, first of all, thanks a lot, Manuel. Very, very impressive, very hard data in a sense, which is very helpful in this context. And well, I already ate into your time, so I don't want to make it too long. What role do export, which is export of agriculture, how do you account for that in your figures? Is that accounted for in the agricultural production?
Yes.
Are you in touch? I mean, that's the obvious question now, but at some point, other questions may point to the same direction. So I suppose Spain can be a self-sufficient food system, I'm wondering, to some extent. This is not the case for, apparently, depending on diet issues, etc., and modes of production in the south of the Mediterranean. So how can we square the circle there in terms of food security where self-sufficiency is not possible? But maybe you can reflect on that.
Yes, I have a picture with this show that our research we have done about if Spanish land could feed the Spanish people. If we have enough land to feed all the Spanish population in using organic foodstuffs. And this is the figure I have no time to explain, but we need 15% of total agrarian surface additional to feed the Spanish population with organic agriculture, organic product, but we need to change the diet, trying to go back to the Mediterranean diet. Now is the best considered, well considered, sorry, by the health services all over the world. This is an important or health diet, but this is using this calculation we have made using a specific tool we have developed named land cost of agrarian sustainability. That how much land we need to have to close this biochemical cycle in order to make sustainable the management of agroecosystem. And for this reason, we have take all the agriculture in Spain, even the territory devoted to forest, devoted to pasture, and all the different land uses, trying to integrate one with another, and in order to make synergies or make internal loops to avoid using input and generating high level of productivity with agroecological approach. This 50% more the land, we can save this, reducing, for example, the consumption of meat or dairy product, even with a more accurate integration of land uses. This is of course, we have calculated this, and it's published in 2016 in open access, well-known journal.
Thank you very much. We have another question by Olfa Majoub. Olfa, do you want to raise it yourself?
Yeah.
Thank you.
Yeah, thank you very much for the really valuable presentation. You mentioned that transport is consuming about 26% of the energy. So what about the exchange of products between the regions? Because we cannot cultivate tomatoes everywhere, or pepper, or any kind of products. So how can we balance this between the region and because we cannot transport food without energy? What is the limit? Is there a way to set a limit? What would be, let's say, sustainable and what would be not?
Yes, this is a very interesting question, because the main problem now in Spain, this is the reason why the transport is the most intensive, energy-intensive activity, is because this is regulated by the market. And we can appreciate that, for example, tomato produced in the south goes to the north, and then part of them go back at the south again, no? Because the rationality is related with the benefit, with the profit of the distribution channels, distribution enterprise or distribution firm, no? Especially supermarket, big supermarket, for example, no? And you can eat tomato produced in the north, and the people in the north can eat tomatoes produced there. The problem is the time when you have to or could you eat tomato. For example, if you want to eat tomato out of season, of course you have to import it. Or, for example, it's very common here, eat grapes or berries coming from Chile in the Latin America. This is a 70,000 kilometers abroad, no? Long. But we can eat grapes, berries, and many other things here, but during the summer, not in the winter. If you want to eat them in winter, you have, of course, to import. That's the problem. You can eat all things, less, for example, coffee or chocolate that we can't produce in Spain. But almost all the food we can produce inside Spain. The problem is also that many of the transport are made by road, with big lorries spending a lot of energy in fridge the food, no? Even established a very dense network of center of distribution. All of them spend a lot of energy, or a lot of energy. If you take, for example, a short channel of distribution, put in relationship, as close relation, the producer and consumer, of course you save a lot of energy. We have assessed, and now we are continue to do that, assessing how much energy is invested in short channel, no? In order to correct or change some inefficiencies that this short channel produce, also because the problem of scale, no? Of scale. For example, many of these agroecological experiences have no enough money to invest in, for example, a big fridge to preserve food, no? For example. But if you put many different small experiences, agroecological experiences, working in net, in a network, is possible collect enough money to get this kind of logistic preservation.
Thank you.
There's another related question. If you could explain more the pillar number 4, more seasonal diet. I think you hinted at that already. So there's something more to say about this. Did you understand the question?
Yes. Try to read the Soraya Susi, the question, no? Put by Soraya Susi, no?
No, that is 2 different questions. The first question is on the more seasonal diet and how it could help reduce energy from the food system.
How reduce the energy from in the food system? This is the question.
I think that's the question.
Yes. The criteria is the 4 criteria we had shown before, no? Establish a close relationship between producer and consumer. This is linking territory with the food, because now, for example, in Spain is decoupled. The decoupling is growing now between territory and diet of the Spanish people. This is the most important. The second is eat food coming from surrounding agroecosystem, and not with out of season, with eating the food that the agroecosystem produce in each time. The third one is reduce the amount of meat and dairy products that the Spanish people eat, because it's costly. Producing meat and dairy product is costly, and not only from a Spanish perspective, but also because this diet, this kind of meat diet, produce a very important or significant impact in Latin America through the import of soya and maize, OGM, cheaper and producing a lot of problem with in the agroecosystem of Latin America. No? And finally, is trying to eat more fresh food. No? These 4 criteria, not of course so simple, but these 4 criteria are combined, are the principle of for redesigning sustainable, or redesigning the real or the actual food system in a more sustainable way. And the second one, I don't remember the question.
I think, Thoraya, maybe you will rephrase your question yourself.
Yes, thank you, Soren. Thank you, Manuel, for this very interesting presentation. In the study that you showed, the data showed that the food system has become one of the most energy consuming activity. And then you showed all these activities responsible for this, and agricultural activities are these are the highest, the one responsible. And when in the data you presented within this agricultural activity, there are animal feed that seems to be, they are consuming a lot of energy. It's 191. So my question, also knowing that in agroecology, animal, it's the role of the animal in the farming system is important. Because of this can be used for waste animal or the excrement as organic fertilizers, reduce the use of chemical fertilizer. So my question, how to balance between these two things? I mean, from one side, the animal feed is contributing to this high energy consumption. And on the other hand, I mean, we in the agroecology, I mean, the presence of the animal it's very important. Thank you.
Okay, thank you for your question. The problem is that the kind of livestock farming that has increased a lot is the intensive livestock breeding. This kind of livestock breeding or farming produce a huge quantity of manure, but this manure cannot be used in agriculture. Has to be destroyed or buried. Why? Because because of high content in antibiotic and heavy metal and the isohumic content is not is not suitable for manure, no? For manure the agroecosystem. Even there are a important cost to transport and to delivery. From an agroecological point of view, we have to integrate livestock into agroecosystem, feeding inside the agroecosystem, not outside, with a lot of feed coming from another country. We have to, but taking into account that this growing of intensive livestock breeding is now the face of the coin. The another face is that the extensive livestock farming, the most important from a agroecological point of view or environmental point of view, that preserve and give ecosystem services, is disappear because the high cost to extensive livestock breeding. This is the two different question, but the main problem, of course, is that the manure produced by intensive livestock breeding, we could say that this is a waste out of place. We name this.
Yeah, thank you very much. I think that's very, very clear and insightful thoughts on the nature of the food system and the way that transformation would have to go towards in order to increase sustainability and reduce energy consumption. Now we have maybe a last question by Andreas. Please, Andreas.
Well, if there wasn't anybody else having a question, I talked a lot already. My question was if there was really no, you talk very little about kind of technological innovations. So I was wondering what role they could play, or why they don't, why they are not mentioned. There is, for example, a vivid discussion in Germany in the organic farming sector, if there wasn't a type of GMO that helps to democratize this technology, taking it out of the hands of large companies, and that could help in producing more food in an organic way and in a sustainable way, environmentally friendly. So is this not discussed, or have you been discussing this with your colleagues, or what role would you give to these kinds of discussion in political agroecology?
Yes, as you know, the agroecological movement is against the GMO crops, no? Of course. But we are now debating or discussing about CRISP, for example, the biotechnological edition. I'm not a specialist, and I'm trying to understand well this new technology. But from if you take into account the agroecological principle, for example, autonomy, the question is that CRISPs and any other new big technologies produced by big companies probably generated more dependency of the farmer from the big company. The problem is the main problem now in the world agriculture all over the world is that the agricultural activity, the farming don't get enough money to live. That's the problem. Even in Germany, even in Spain, the small, of course, no? Because they are the closed market for the big corporation that sell machinery, pesticide, seeds, and so on. This is the main problem. So this kind of technologies are not suitable to avoid or to suppress or erase this problem. Probably intensify the dependence of the farmer from this kind of firm. And of course, they are not the solution, of course.
Thank you. There's one last thought by Olfa Madyub. What would be the fate of greenhouses producing extra seasonal products if Spain decides to shift to eating seasonal products? So would we get rid of greenhouses altogether?
And now we are trying to calculate the whole emissions, all the greenhouse gas emission of the whole diet, the Spanish people. No, we need to know more in detail what is the amount of each food in terms of emission to properly answer this question. But of course, meat and dairy products are so costly in terms of emission. Also, the food processed or super processed food. No, of course they are. So if you want to reduce the greenhouse gas emission, we have to change our diet. I have another picture showing work developed by us in 2018, try to model 3 different scenarios of emission of gases, depending of these 3 different kind of diet. And the most Mediterranean diet is, of course, the less emitting diet, no? And this is the most sound diet that we could practice, of course.
There's another question, but I think we're at the end of the 1-hour session. So again, thank you very much for your very insightful ideas. And we look forward to learning more about this. And I already shared the link to the open access book. And yes, we look forward to following your work and getting into dialogue also with the project. And yeah, I hope this is the beginning of a very lively discourse and discussion on sustainability in agriculture, and also the shifts and transformations that are necessary for a more sustainable food system altogether. So thank you very much.
Thank you. Thank you for you and for Nicholas.
And for this, I think with this, we are at the end. We would yeah, first of all, thanks also to Abed, who was organizing everything in the background, and also American University of Beirut in general for the cooperation and setting up the webinar series. We have the next session on October 13th. And thank you for sharing this, Abed. The next session is entitled Mediterranean Food Systems in Conflict and Crisis, and Professor Rami Zurek, chair of the Food Security Program at AUB, will talk to us there. And here in the chat, you can find the link for registering. It will have a very similar format like today. And yes, with this, I hope you enjoyed this webinar exchange. Thank you for being there and for taking part and raising questions. And yeah, please follow us in our efforts with the Aurora project. Thank you very much and have a great evening, everyone. Thanks.
Thank you.
Ciao. Ciao.
Thanks, Manuel. It was very interesting.
Thank you, Doctor.
Okay. I try to talk with you next.
Yes, that's for sure.
Next time.
Yes.
Okay.